Hi, so I am going to talk the next 15 minutes about a Department of Energy national user facility called Atmospheric Radiation Measurement Facility. And it's a long-term atmospheric observatory facility. And next month, we are going to be 30 years in operation, continuous operation. So I'll talk about how we manage the data and as well as how we are looking at adapting AI for a couple of different, I guess, missions. So first, the programmatic mission, ARM, which is providing atmospheric observational data to understand the Earth system models, and especially with the clouds and aerosol and their interaction with Earth's surface. So that's a very high level scientific mission. And we are the world's foremost ground-based atmospheric observatory facility. I will tell you why we consider ourselves on that. We have been collecting data since '92, and we have over almost 500 really complex set of sensors that we deployed to measure key parameters from our atmosphere, from atmospheric state to surface energy balance, aerosols, and aerosol properties, and aerial measurements, radiation reflective measurements, and so many. Last time I checked, we measure about over 2,000 measurements from this set of sensors. The map that you see there, the blue dots represent our three primary observatories, one in Oklahoma and one in Barrow, Alaska. The other one is in a small Portuguese island called Azores. And all the gray ones that you're seeing, those are our mobile facility. And we actually have three of those mobile facility. We ship these multiple container full of instruments and study different climate phenomena. We went to Arctic as part of this Mosaic campaign, which is a drifting exercise from Central Arctic to south. And we collected over 60 data streams in there. And then right now we are in a Tracer campaign, which is in Houston, and the other one is in Colorado. On top of it, we also have a aircraft facility where we collect atmospheric parameters from there. Okay, so in this diagram, you're seeing the left side, all the blue blue boxes. Those are all our data sources, and these continuously feed the data from these observatories to the ARM data center here at Oak Ridge National Laboratory. And so as soon as we receive the data, most of them are near real time, streamed to us. And then we go through multiple automated ingest processing, as well as higher value added product generation, and automated data quality checks, as well as manual verification. So all this happens continuously, and ARM is managed by 9 different labs. And the University of Oklahoma helps us with the data quality operations. So and users will be typically given the data in a record amount of between 24 and 48 hours of collection, with full data quality checks included. And then we also continue to improve the quality, and then we communicate to the users who download the data. So on top of it, we provide a community compute cluster for our users to do the actual analysis. So we currently hold over 11,000 data products. And last time I checked, it was about 3.5 petabytes of data, was from all the way from 1992. Okay, so at ARM Data Center, we do end-to-end data service, and we follow the FAIR principle. I mean, all the presentations that you heard the last 1 hour or so, you hear the importance of FAIR and how the programs like Neon following the FAIR. Very similar. ARM is also following the FAIR principles. And we actually confirmed that with I guess like certification agencies. So we got the Core Trust seal given by the International Science Council as part of the World Data System. So we got that certification, and we also got a certification from DOE on the public reusable repository PURI data resources, and so on. So these certifications are good for every 3 years, and they re-evaluate. And so this is how we are conformed to the FAIR principles. Okay, so the rest of my slides, I'm going to touch the key upgrades that we are looking at doing to support the AI missions. And so all of our observatories are tied with the site data system, very robust site data system that we were able to operate from Arctic to Antarctic, basically, in multiple climate regimes and very challenging environments and moving platforms too. So we recently added our capability to near real-time data access, and we are working on enabling edge computing to not only help our scientists, but also like for things like radars produces terabytes of data, and we have 30 of those radars. Looking at doing a data reduction right where the data is collected. So multiple edge computing use cases we are trying to get into. And so yes, you can visualize, right? Like we have over 11,000 data products and like so many, I guess like terabytes of data. So our users are challenged with so many options for anything that they search for. So we came up with this idea of data recommender system, and which uses data quality information and completeness and temporal and spatial coverage. And so we effectively used our data scientists and subject matter experts to create something like a tweet-like recommendations for users to quickly get into the data based on their use case. So we have done that for all these data streams so far. Like we have over 1,300 recommendations that is covering these 11,000 plus data products. Okay, so all this takes us into the next big challenge, which is keeping up with data discovery. And this is our 5th iteration of data discovery tool since I joined ARM back in 2000. And the version that you will get access when you go to arm.gov, it's a remarkable product. I'm saying that primarily because we started with reaching out with our stakeholders, and I essentially had about 30 different calls for different groups of stakeholders and try to understand their pain points and like what is working best, what is not working good. So we gathered that 92 plus group of recommendations from users, and then we developed this the user interface along with some usability team help from University of Tennessee. So we effectively introduce this data recommendation and data tagging based on epochs or golden period. So those concepts are integrated in this data discovery. And so the screen that you see on the bottom of this slide shows like how we integrated the data availability along with the data quality. So users can quickly drill down to, oh, so there is this suspect data for this particular period of time. Let me look into that detail. So they can, with one click, they can see the information, and then they can say, give me the data only like that you think it passed your data quality check. So we actually filter out those bad data points and then give it to the user, or they can choose to get the full data. Okay, so all these are done through a very robust cyber infrastructure. And the wireframe that you see there, it shows how the data arrives from our observatories and then get into our processing environment. But then, like you see that Cumulus cluster, which we are using it for not only for large-scale data processing, but also for high-resolution model generations, and also for users who can access or request access to this computing cluster, so they can use or readily all these 3.5 petabytes of data. Okay, so thinking about the next generation data capabilities, so we are heavily investing our resources in terms of enabling machine learning and AI platform for users to readily use our data, as well as bring in other data. And also we are building a deep learning software stack expertise within the On Data Center, so users can make use of our expertise. And we recently launched new visualization and Jupyter Notebook capabilities for users to quickly get into our HPC using Jupyter Notebook, and then develop their script, and then a request to run it in those like hundreds of nodes or tens of thousands of cores, computing cores, to do their, I guess, like data analysis or visualization. Okay, so we recently did Jupyter Notebook training during the last earlier this year's American Meteorological Society workshop, where we trained about 40 users or participants on how to use the Jupyter Notebook and how to use the ARM data for any climate related research. So, okay. So talking about data interoperability, you have seen Christine and many others talk about how the schema.org and other metadata standards helps us provide the data or make our data visible in other portals and clearinghouses. So we do the very similar approach. So we have a robust operational level metadata, but we export that into one of the community followed standards like ISO or CF or schema.org. And we are providing our metadata to a bunch of these gateways, both national and international, including the Google data search, and for users to quickly discover the data. But then we provide endpoints for them to download the data. So we don't really distribute the data to other portals, primarily because our data evolves all the time, and we need to communicate to our users if there is a change in data quality or if there is a new version available. So it helps us keep the latest and greatest version of the data and give it to the users. And so we are also developing a new concept called Data Workbench, which is going to be a FAIR-based web services where users can essentially use ARM data wherever the capacity exists, or bring in other data like Nextrat, Modis, or Neon, or any other data, and develop a mashup data analysis or something. Okay, so Christian, I asked you about a question about the DOI, and we also have an exact same challenge. And a few years ago, we developed a data citation strategy. We still assign the DOI at the data product level, but then we provide a data citation generator for users to essentially export a citation using the DOI. But in one of the accepted formats, we provide a bunch of those formats already available through an API service. But the user can just copy that citation, and then the expectation is they use that citation in their publication. And when a future user wants to download the data, as long as they use this structure, which has the DOI along with spatial and temporal information, they will be able to drill down to the exact data that they're looking for. So this is still a very evolving concept, and we are trying to explore things like nested citation and on-the-fly citation generation for combination of specific data, user access, user ordered data sets, so things like that. Okay, so looking ahead, so this is my summary slide. We are looking at applying AI for two concepts. One, to improve our data operations. As I mentioned, the edge computing where the data is getting collected, and all the way to provide advanced recommendations to the users using AI concept as well, but also provide our data in AI-ready format. And there are quite a few initiatives that are currently happening where people are looking at developing a rubric type validation to say, yes, this data is AI ready. So we are looking into applying those as well. And yep, so that's my final slide. And I think the next presenter is Bruce Berryman. He's going to talk about application of FAIR principles in astronomy.